Now, what's interesting about chemistry is all these ideas that keep, this is the quantitative part, the number part of chemistry. They're going to continue to build up and use old ideas. We're going to now add the idea from how many particles and how many moles of something we have, and we're going to put those in with not just elements, like you learned the elements' names and you learned how to balance them. We're going to now use them in a formula. And here's actually the whole end game of why we've been trying to get you to understand these moles. First of all, when you have a formula like this, where you're going to take and burn something like benzene, which is fuel, you can burn it, then you first have to do is get a balanced equation. Okay, and you've been doing these balanced equations up until this point. And you'd say, well, 2 of the benzenes is going to take on 15 oxygens, making 12 carbon dioxides and 6 waters. What's going to be happening is, just like a recipe keeps track of all these amounts, now scientists are going to say, well, geez, if you need so much energy, you got to go a certain distance. They'll calculate, saying in order to make that much energy, we may need 15 moles of benzene. And 15 moles of benzene is going to create how much water or how much carbon dioxide, for instance. And so you're going to be able to give a starting amount here as one side, and we're going to work our way to the other side of the equation to figure out how much is produced. So that's called stoichiometry. Stoichiometry is the math of chemistry. Now, don't get too crazy or too scared or any of that kind of stuff, but I do want to help you realize that almost all of these problems are going to go along a certain path. They will always follow this path. You may just start it a little bit further down the path, or higher in the path and stop. But those are going to be from grams of what you were given, the given material in the problem. Now, you're going to change that to moles. That's always the first step. Change from grams to moles of what was given. And then from that, once you know the moles, these balanced formulas are actually mole ratios. It's saying, hey, two eggs plus 15 cups of flour gives you 12 cupcakes and 6 amounts of water vapor. Okay, so these are just formulas, and they're 2 parts to 15 parts to 12 parts to 6 parts. And when you're in moles, then you're talking about parts. So that's why you're going to always change the grams of one of these given ones. You're going to change it into moles of that given one, and then from one to the other, you can get that ratio. It's 2 to 1, for instance, or 2 to 3. That'll get you into moles of what's being asked for in the problem, moles of wanted material. And then from a lot of times they're going to say, well, how many grams is that? They want to know by mass, because you want to say, hey, we need to create, 12 grams of carbon dioxide, then how much of this starting material do we need? So let's go through that process and see an example. I'm going to leave this little steps of the path. It always has a little ring to it. Grams given to moles given. Moles given, moles wanted to grams wanted. Or grams to moles wanted to grams again. So you're going to start with the grams of something. Here's your given information. Okay, here's what was given. You're going to change that into what's wanted. Now, I'm going to just step back for a second. I'll do it in both paths. Remember, we learned 2 ways to change these. I'm going to do it first in this conversion fraction method, okay? So we can see what that looks like. If I've been given 78 grams of this benzene, and I want to change that into how many grams of water when we burn it, how much water is produced by this, you're going to write down the given. Here's the given. You're going to write on the right-hand side what's being asked for, which is the grams of water. Okay. Now, in order to get there, I'm going to make a step along each path, and step along each step of this path, and I'm going to say, oh, I'm going to change from grams of given to moles of given, and usually that's going to come from the gram atomic mass of the material. So if I'm starting off with grams of C6H6, I need a fraction that changes me to moles of C6H6. That's what this first step says. Well, remember, whenever you start with a given amount, you want to put that unit in the bottom, and you want the unit of what you're going for, which is moles of C6H6 on top. If you remember, 1 mole is whatever each of these atoms weighs. 6 carbons each weigh 12. So that's 72 grams plus 6 more, 78 grams. Okay, I just had to look that up on the periodic table. So 1 mole is 78 grams. This is an equal amount, so that's why we can multiply that by this starting material. 1 mole is 78 grams. The grams goes in the bottom because you started with grams of benzene there, and I'm changing it to moles. Okay, that's what you did. You went from grams given to moles given. Now, from moles of given, I want to get to moles of what's being asked for, which is water, moles of water. So what's going to go? Whatever this previous numerator is, goes as the unit, not the number, but the unit. moles of C6H6. You went from moles of C6H6 on top to moles down here, and then I want to go to what is wanted, which is asked for water. You're going from moles of C6 to moles of water. Now, where did these numbers come from? These numbers come from the balanced equation. So that's why your first step in all of this stuff is you got to balance the equation. So I look in here, there's a 2, oops, there's a 2 there. Let me get that taken care of. There's 2 C6H6s, that's going to go right there. And how many H2Os? 12. Okay, they react in a 12 to 2 ratio. That's now changed from grams a given into, moles of C6H6 into moles of water. The last step, I'm going to go from moles of water to grams of water. Now, all the problems I'm going to have you guys do is going to be this step-by-step process from grams given to grams of the end material so that you get the hang of this process. All right? So I've got 12 moles of water. That moles of water has to go on the bottom, and you're going to change it to what's being asked for, which is grams of water. Now, I know 1 mole of anything weighs its gram atomic mass. So here's where I just look and say, well, which one is 1? Well, the word mole is, 1 mole is what you want to pull from. So that's going to go at this bottom amount. The only reason mole's on the bottom is because it was on the top of this previous fraction. Top part goes to the bottom part. So when you multiply these all out, all those terms fall away except the one you want. How much does H2O weigh? 1 mole of H2O weighs 2 for the hydrogen and 16 for the oxygen. So that's 18 grams. All right, so now there's 3 fractions that get you from grams of given to moles of given. From moles of this benzene to moles of water, which is wanted. Moles of wanted into grams of wanted, and that'll now be your answer. So what do I do to get this? Take 78 and divide by 78. I just chose a 1 mole amount, so that ends up canceling. Okay, and this is now times 12, divide by 2, so you take 78, divide by 78. That's 1. Times 12, divide by 2. That's actually 6, right? 6 times 1. 6 times 18 is 60 plus 48 is 108 grams. If you do that by calculator, you should be able to come out to that 108 grams. So 60, 48, yeah, 108. So that is how I changed this. Notice I went from grams of what was given. This fraction changes me to moles of what's given. This fraction changes me moles of what's wanted. This fraction changes me into the unit that's wanted. Okay, and usually it's grams. Awesome. So that's the factor label method. If you're used to using those, let's try one more problem. Sorry, let me clear that ink. And I'm going to choose a different step. I'm going to use this heart method down here. Okay, it can help you organize this process as well. So I have a problem that's right here. And what kind of reaction is this? Let's see if you can practice these. You know what? Go ahead and let's do those problems first so you get a little bit of practice, and then we'll come back to this.